Now my graph is a little bit cluttered, so I will make a new one on the next page. So again, we're going to base the graph of g of x off of the graph of y. And there we have the beginnings of our graph of the cube root function. And our nice symmetry. We connect that all up. Now what we're going to do is take every point and scale it by a half. In other words, make it half as tall. So the origin, if we make that half as tall, is going to stay put. This point has a height of 0, so it can't get any shorter. This point at 1, 1 can get half as tall. That resulting point will be at 1, 1 half. Our point at 8, 2 can get half as tall, and we get the point 8, 1. And on the other side, we'll see similar behavior. Negative 1 becomes half as far away from the x-axis, as does the point negative 8, negative 2. So notice that we're dividing the distance by a half. If this were a third, we would divide the distance by a third. If it were 3/4, we would find points 3/4 as tall as the ones that we are given. So there we have our nice compression. So in these two examples, we've observed that when c is small, when our constant scalar multiple is smaller than 1, we are going to compress our graph. But when c, the multiple, the scalar, is larger than 1, we stretch our graph. So it gets taller than it is originally. If that constant is greater than 1, it gets shorter. If that constant is less than 1. But what if we wanted to multiply by a negative number? Well, this actually manifests as two transformations. We can think of this as negative 2 cube root of x. Now, since I already know what the graph of 2 cube root of x looks like, I could take the graph of that and flip it vertically. I can reflect the graph of 2 cube root of x across the x-axis. So there we have two transformations taking place at once. First, we would graph the cube root function, then we would stretch it by 2, and then we would reflect it across the axis. So I'll take the graph that I've already come up with, 1, 2, (8, 4), negative 1, negative 2, negative 8, negative 4. Remember, this is what happened when we stretched the cube root originally. And I will reflect it. So every one of these points will get reflected across the axis. Now my y-coordinates are going to be made negative. So this point reflects across. This point reflects across to 8, negative 4. This point reflects across to negative 1, positive 2. And this point reflects across to negative 8, positive 4. And do your best to connect those graphs up. It can be a little bit funny sometimes, a little squiggly, but just try to do your best to get that shape to look as it should. So there we see two transformations, our final graph, -2 cube root of x. They're decreasing from left to right. So the final concept in this section, which can be a bit tricky, does require some practice and a good deal of familiarity with each of these types of transformations, involves situations in which multiple transformations are taking place within the same function. So, for instance, if I wanted to graph f of x equals the square root of -x plus 2 minus 5, where I might begin would be to decide what transformations I think are taking place in this function. Now, a bit of reflection and a bit of practice will lead you to the conclusion that a horizontal transformation and a vertical transformation can occur in any order. For instance, shifting a graph up 2 units and to the right 3 units would result in exactly the same graph as shifting to the right 3 units first and then shifting up 2 units. So the only thing that we need to worry about is whenever we have the same direction of transformation. So the order of horizontal transformations does make a difference in the final graph. Similarly, the order of vertical transformations makes a difference in the final graph. For example, if I take the square root and I reflect it first horizontally, and then I shift horizontally to the right, I do not achieve the same result as if I shift horizontally first to the right and then reflect. So here I see my final graph from reflect, then shift, whereas here I see the final result of shifting, then reflecting. And by similar reasoning, if we stretch a graph, for instance, if we stretch the square root function vertically and then shift, we see a very different result than we would if we shifted first and then stretched. So notice that my starting point also gets stretched, unlike in the case of the original graph. It's a little hard to see on here, but if you play around with some examples, you can see that the order of these actions does make a big difference. So the question is going to become, which should we do first? So going back to our example, what do I think is happening with this graph? Well, we appear to have a vertical shift where we move our function down 5 units, and we appear to have a couple of horizontal actions. Looking inside of the function, we have -x, which would lead us to conclude that there is going to be a horizontal reflection. And our +2 inside leads me to believe there will be a horizontal shift And I think since we are adding 2, we are going to move in the negative direction 2 units. So the only ambiguity here is, should we reflect first and then shift, or should we shift first and then reflect? And the way that we can determine which of these would be correct would be to make a function that does each of those possibilities. Alright, so a function f of x, we are going to be square rooting, and we're going to go ahead and subtract 5 because it doesn't really matter when we shift vertically. The only trouble is when to do things horizontally. We can do the horizontal stuff first and then shift vertically. We can do the vertical stuff first and then shift, deal with all of our horizontal transformations. It does not really make a difference. Alright. So here I am going to create a function f of x equals the square root of x minus 5. This is the same type of function as we see here. The only thing happening with this function is the vertical shift. Next, let's apply the reflection. So h of x with the reflection would look like negative x. To achieve that reflection, we would replace x with negative x. So we achieved the downward shift, we achieved the reflection. Now, the final step will be to shift horizontally. So let's say k of x. This function, remember, to achieve a horizontal shift, if I want to shift h of x to the left 2 units, I will replace x in that function with x plus 2. So instead of x, I'll put x plus 2. Now, I would like to see, is this function the same as the one that I'm supposed to be graphing? Well, the negative actually distributes over the parentheses, and this function is really negative x minus 2 minus 7. This is not the square root of negative x plus 2 minus 7. So we determine that that order, vertical shift down 7, then reflect, then shift left 2 units, was not described by this function. So maybe we want to shift down 7 units, then shift left 2 units, and then reflect across the y-axis. So let's see what that function would look like and make sure that it does what it's supposed to. So if we have f of x equals the square root of x minus 7, this will take care of the downward shift. Then in order to shift to the left, we need to replace x with x plus 2. So g of x, based off of the function we just came up with, instead we'll have x plus 2 minus 7. Okay, so this one shifts to the left 2 units. And finally, to achieve the reflection, we need to replace x with negative x. So the only thing I'm going to change now is replace x with negative x. And this is exactly the same as the function we are attempting to graph. So this order of transformations is correct. Now alternately, we could have shifted to the left 2 units first, then reflected, and then shifted down. But again, horizontal and vertical are independent of each other. So the only trouble we run into is when we have multiple horizontal or multiple vertical transformations. Alright, so let's get down to graphing this thing now that we know what it looks like. We know it's going to be based off of the graph of the square root of x, so let's graph that guy and go from there. So the square root passing through 0, 0, 1, 1, 4, 2. If you want to be really ambitious, you can go all the way out to 9, 3. Alright, there is our basic function. And I'll use a dotted line for now so that when we're finally done, we can see what the graph really is. Okay, so we'll begin by shifting, I think I will use this second approach. I'll shift to the left 2 units first. So every point gets shifted 2 units to the left. And again, my basic shape remains the same, so this is our first version. Our second step is going to involve reflecting across the vertical axis, across the y-axis. So I'll start with our leftmost point. If I reflect that guy, he'll end up there. If I reflect this guy, he'll end up right there. If I reflect the point 2, 2, it will end up at negative 2, 2. And this guy, 7, 3, will end up at negative 7, positive 3. So there we have step 2, our reflection taken care of. And finally, we'll move the entire operation down 7 units. So every point gets to move down 7 units. 1, 2, 3, 4, 5, 6, 7, down to negative 2, negative 5, and negative 7, 2, 3, 4, 5, 6, 7, negative 4. So our final graph should look something like that, with a little bit of wiggle room for allowing for me not being the best of artists. Now these are very easily confirmed in your grapher. If you power that on and you plug in the function that we're trying to graph, f of x, aka y, equals the square root of negative x plus 2. Make sure you close that off and put the negative 7 way outside the square root. And we'll hit graph. Now, if your window is not standard, you may have trouble seeing this, so I would zoom and then choose option 6, zoom standard. And there we see something that looks exactly like what we came up with. Now, just to confirm that all of our points ended up in the right place, remember we have 2, negative 7, 1, negative 6, negative 2, negative 5, and this is where it's really handy to keep track of those points. Let's see, we had negative 7, negative 4. I will go to the table, and my table is a little strange at the moment, so let me go back to the standard setup. If I start at 0 with a step every 1, I'm going to have some errors show up. As soon as I'm past 2, I get all these errors. And that makes sense. My function should only exist to the left of positive 2. And when x equals 2, we get y equals negative 7. When x equals 1, we get y equals negative 6. So we're on track with those first 2 points. And if I scroll up a little bit, when x equals -2, y equals -5. When x equals -7, y equals -4. So chances are we didn't stumble into that by accident. This is indeed the graph of f of x. So that's one way to handle it. Make a list of all the transformations that you see, and then try to create or recreate the function using those transformations in various orders. Only one order should work. Well, depending on the independence of your horizontal and vertical transformations. As we saw, there were actually 2 ways we could have done this. If we had shifted down first, if we had graphed something like that, then shifted to the left 2 units, and then reflected, we could also have achieved the same result. But you should come up with the correct result, the correct order, or a correct order, by performing this process. And remembering exactly what needs to occur in each step of that process in order to achieve the transformation that you are hoping to. The alternate, if you feel that that is a little labor-intensive, on the next page of the notes you will see a sort of order of operations for transformations. Now that order of operations only works as long as your function is set up exactly as we see it. So if you have a function f of x equals let's say g of x, the function we're hoping to graph, is based off of a function f with b times x plus c inside and plus d outside, we are going to reflect vertically and stretch we are then going to reflect horizontally, potentially. Then we are going to shift horizontally. And then finally we are going to shift vertically. So if you can write your function in this paradigm, in this form, you can follow that order. For example, if we go back to the function we just graphed, f of x equals the square root of negative x plus 2 minus 7, notice that this is not in the form that we need. Our function, our outer skeleton, is the square root. So we need the square root. Now inside, I should have x plus c in parentheses, and if I have a negative, I want to factor that out. So this could factor out as x minus 2 minus 7. Now in this form, here we have b, c, and d. We don't have an a, but that's okay. We don't always need to have everything. So we are going to reflect horizontally. Then we are going to shift horizontally. But notice here I now have x minus 2, so we're going to shift to the right 2 units, and then we're going to shift down 7 units. So we have a different version of the horizontal shift, and we're doing these in a different order. We're reflecting first, and instead of shifting to the left, we're now shifting to the right 2 units. Let's see how that turns out. So again, I'll start with my basic function. 1, 2, 3. And I won't use quite as many points because I think we kind of see the idea here. So there is our basic function. We are going to reflect horizontally, so we're going to reflect across the y-axis. This point will remain the same. 1, 1 will reflect across to negative 1, 1. 4, 2 will reflect across to negative 4, 2, and we see our first transformation gives us that result. Then we are going to move to the right 2 units. So if I move this point to the right 2 units, this point moves to the right 2 units, this point will move to the right 2 units. We see how C manifests. And finally, we'll shift the whole picture down 7 units. And see where that leaves us. So this point will move down 7. This point will move down 7. This point will move down 7. And our final picture looks exactly like what we came up with before. So those are a couple of different ways you can handle those types of problems. One way is to put it in this format. Make sure you factor so that you have x plus or minus something and just x. So we don't want any negatives in there. If there are any constants out front or out back, those will occur in that order. We will deal with the stretch and reflection vertically first, and then we'll deal with the vertical shift dead last. Alright, so that is how we're going to handle things in this section. Go ahead and get started on those homework problems, and bring any questions you have to class.